Ever wonder why we use soap every day? It's something we do almost without thinking, a simple act that's become part of our daily routine. But have you ever stopped to ask yourself what's really happening when you reach for that bar or pump that dispenser? It's not just about looking clean or smelling nice. Soap is a powerful tool for our health. It's a silent hero, working behind the scenes to protect us from things we can't even see. The world is full of invisible germs, bacteria and viruses that can make us sick. These tiny invaders are everywhere, lurking on surfaces, floating in the air, and waiting for a chance to hitch a ride on our skin. These germs stick to our skin, especially our hands, as we touch doorknobs, play outside, or pet animals. Even when our hands look clean, they can be covered in millions of microscopic hitchhikers. Soap is our first line of defense, washing away these invisible invaders and keeping us healthy. It doesn't just rinse off dirt, it actually breaks apart the germs, making it easier for water to carry them away. Our hands are like busy transportation hubs for germs, spreading them to our faces, food, and others. Every time we touch our eyes, nose, or mouth, we give germs a chance to enter our bodies. Using soap is like setting up a security checkpoint, stopping germs from traveling further. It's a simple step that creates a barrier, protecting not just ourselves but everyone around us. That little bar of soap is more than a cleaning product. It's a guardian of our well-being. It's a tiny shield we use every day, often without realizing its true power. When you wash your hands, you're not just removing dirt, you're performing a science experiment in your own sink. Each bubble is a mini-lab, trapping and lifting away germs with every scrub. Soap uses its chemical properties to protect you and your family. The molecules in soap are specially designed to break down oils and germs, making them easy to wash away. It's a small habit with a huge impact. Just a few seconds of lathering can prevent illness and keep everyone healthier, from the youngest to the oldest in your home. Understanding the science behind it makes it even cooler. The next time you see those bubbles, remember, they're working hard for you, even if you can't see the results right away. We bother with bubbles because bubbles mean business, the business of being clean and healthy. They're not just fun to play with, they're essential for keeping our world safe. So next time you reach for soap, remember, you're using science to stay safe. You're taking a stand against germs one wash at a time. Let's dive into how it all works. Get ready to discover the amazing world of soap and bubbles and why this everyday habit is one of the smartest things you can do for your health. When we wash our hands, what exactly are we trying to get rid of? It's a question we rarely stop to consider, but the answer is more important than you might think. The answer is twofold. We're washing away both dirt and germs. Dirt is the stuff you can actually see, mud from the garden, grease from cooking, or food smudges after a meal. These are mostly made up of oils, fats, and tiny particles that stick stubbornly to our skin. These oily substances are what scientists call hydrophobic, which means they repel water and don't dissolve or wash away easily. That's why if you try to rinse greasy hands with just water, you'll notice the water simply beads up and rolls off, leaving the grime behind. But there's another, more invisible threat lurking on our skin: germs. These are the tiny organisms we can't see, but they're everywhere. Bacteria and viruses are microscopic life forms that can cause infections and disease, even though they're completely invisible to the naked eye. Some bacteria, like Salmonella or E. coli, are notorious for causing food poisoning and can make us very sick if they get into our bodies. Viruses, such as those responsible for the flu or COVID-19, are even smaller and have a protective fatty outer layer that helps them stick to surfaces, including your skin. Both bacteria and viruses are experts at clinging to the oily layer on our skin, hiding out in the grime and waiting for a chance to enter our bodies. When you wash with water alone, it just slides right over this oily grime, leaving most of the germs untouched and still on your hands. Think of it like trying to clean a greasy frying pan with only water. The grease stubbornly stays put, and so do the germs. That's why we need something more powerful, something that can break through that greasy barrier and lift away both dirt and germs. This is where soap comes in. Soap is specially designed to attack both the visible dirt and the invisible germs. When you lather up, soap molecules surround and break down oils, lifting away grime and trapping bacteria and viruses so they can be rinsed off. Soap doesn't just clean what you can see. It also helps remove the dangerous microbes you can't, making your hands truly clean and safe. So every time you wash with soap, you're fighting a battle on two fronts, against both dirt and germs, and you're coming out on top. Next, let's take a closer look at how soap actually works its magic to keep us healthy. So what exactly is soap? It's something we use every day. But have you ever wondered what makes it so effective at cleaning? Soap is more than just a bar or a liquid in a bottle. It's a fascinating product of science and chemistry. At its core, soap is the result of a simple yet remarkable chemical reaction called saponification. This process has been used for centuries, dating back to ancient civilizations who first discovered how to turn basic ingredients into a powerful cleaning tool. To make soap, you mix fats or oils. These can come from plants or animals, with a strong alkali like lye. The reaction produces soap and glycerin, a natural moisturizer that's often left in high-quality soaps to keep your skin soft and hydrated. But what really gives soap its cleaning superpowers? It's all about the unique structure of soap molecules. Each one has a double-sided personality, making it a true hero in the world of cleaning. On one end, you'll find the hydrophilic head. This part of the molecule absolutely loves water and is drawn to it like a magnet. On the other end is the hydrophobic tail. Unlike the head, this tail avoids water, but is attracted to oils, grease, and fats, the very things we want to wash away. This split personality is the secret to soap's cleaning power. It allows soap to interact with both water and oily dirt at the same time. When you lather up with soap and water, these molecules spring into action, forming tiny structures called micelles that trap dirt and oil. The water-loving heads reach out to the water, while the oil-loving tails burrow into grease and grime, surrounding and lifting them away from surfaces. Soap molecules act as a bridge, connecting oily dirt to water so it can be rinsed away easily. They're perfectly designed to connect what normally doesn't mix, oil and water, making cleaning possible. It's not magic, it's pure chemistry at work, harnessed by humans for thousands of years. As soon as you add water and start scrubbing, these microscopic agents get ready for their mission, breaking up and removing dirt from your skin or any surface. In a bar or a bottle, soap molecules are packed together, but once they meet water, they become cleaning superheroes, working together to keep you clean. The secret lies in the structure of each soap molecule. This is the key to its incredible cleaning power. So next time you wash your hands, remember, you're witnessing a tiny, invisible army of molecules in action, working hard to keep you healthy and clean. Picture your hands after eating greasy pizza. As you lather with soap and water, millions of soap molecules get to work. The oil-loving tails dive into grease, while the water-loving heads stick out into the water. Soap molecules surround oil droplets, forming tiny spheres called micelles. Micelles trap the grease inside, making it water-soluble. This clever trick lets water wash away what it normally can't. Without soap, oil stays stuck. With soap, it's captured and rinsed away. When you rinse, water grabs the micelles and carries away the trapped dirt and germs. Your hands are left truly clean, thanks to molecular teamwork. Soap acts as a bridge, connecting oily messes to water. That's the beauty of soap in action. The science of soap isn't just for hands, it's everywhere in your home. Washing dishes? Soap's micelles grab greasy food residue and let water rinse it away. Laundry? Detergent, a type of soap, lifts oils and stains from fabric, then the rinse cycle washes them out. Shampoo? It's liquid soap for your hair, removing excess oil and dirt for a clean, shiny look. The same principle applies. Soap molecules surround and lift away oils, dirt, and germs. Whether it's your body, dishes, or clothes, soap is the universal cleaning tool. Water alone can't handle grease, but soap makes it possible. Every time you see suds, you're witnessing soap's power at work. From the kitchen to the shower, soap's science keeps everything clean. That's why we rely on it every day. Soap doesn't just remove germs, it destroys them. Viruses like the flu or coronavirus have a fatty outer layer. Soap's oil-loving tails wedge into this layer, prying the virus apart and making it harmless. The virus literally falls to pieces, unable to infect you. For bacteria, soap lifts them off your skin by breaking up the oily layer they hide in. The friction of scrubbing, plus soap's micelles, dislodges bacteria and washes them away. Some bacteria have membranes that soap can disrupt, causing them to leak and die. Soap fights germs with a 1-2 punch mechanical removal and chemical destruction. It's a simple, brilliant way to stay safe from microscopic threats. Every wash is a microscopic battle, and soap wins. That's the power of chemistry in your hands. How much better is soap than just water? Let's compare. Rinsing muddy hands with water might remove big clumps, but oily grime and germs stick around. Water and oil don't mix, so water alone can't lift away the sticky film or the germs hiding in it. Washing with water alone gives a false sense of cleanliness. Add soap, and everything changes. Soap molecules break the surface tension, latch onto grease, and form micelles that trap dirt and germs. Now water can grab the micelles and rinse everything away. The result? Truly clean hands, not just clean-looking ones. Studies show soap and water remove far more bacteria than water alone. It's the combination of soap's chemistry and your scrubbing that makes the difference. Soap is the undisputed champion of clean. Don't settle for less. Always use soap. Soap science is full of fun facts. Ever wonder why soap makes bubbles? Soap molecules make water film stronger, trapping air and creating bubbles, a sign your soap is working. Hard water, full of minerals, can make it harder for soap to lather and clean, leaving behind soap scum. Soft water lets soap work more effectively. Soap making is ancient. Babylonians made it over 4,000 years ago by mixing animal fats with wood ash. Antibacterial soap isn't better for everyday hand washing. Plain soap and water are just as effective. The key is scrubbing and rinsing, not special chemicals. The most important factor is your washing technique and time. Plain soap is a powerful, proven tool for staying clean. Ready to wash like a scientist? Here's how. Wet your hands with clean running water. Cold or warm, both work. Turn off the tap, add enough soap to cover all surfaces. Lather and scrub everywhere. Palms, backs, between fingers, under nails. Scrub for at least 20 seconds, about the time it takes to sing Happy Birthday twice. This gives soap time to break down grime and destroy germs. Rinse thoroughly under running water to wash away soap, dirt, and germs. Dry with a clean towel or air dry. Dry hands pick up fewer germs. Every step uses science to keep you healthy. Make hand washing a habit, and you're using chemistry to protect yourself and others. That's smart, simple science in action.